So 2b, the discriminant of a quadratic is what we're going to be working on. So all you need to write down and know is the delta symbol. So delta symbol in this case represents the discriminant, which represents b squared minus 4ac. Now, take your mind back to the quadratic equation. If you have a think about it, the quadratic equation looks like this. Now, the discriminant, if you have a close look, is this part, which is inside of the square root. Now, there's a reason we look at that particular part and call it the discriminant, because it actually tells us information. If we figure out b squared take 4ac and just look at that component, it tells us some information. And I'll tell you what those information are. So, as you can see, we will have kind of three information. So we have three cases. It can be greater than 0, it could be equal to 0, and it can be less than 0. And each of those cases will tell us how many answers basically we get and what type of answers. So have a think about it. If I tell you that under a square root, our discriminant, b squared take 4ac, ends up being greater than 0, what do you think? Square root of a greater than 0 will give me, like, for example, a positive number, 11, will give me some answers, right? It will give me two answers because there's a plus and minus associated to a square root. So this will give me two distinct real roots. That means it'll give me a plus square root 11 and a minus square root 11, whatever that discriminant may be. So these are the two answers we get. Now, so that's the first dot point. Second dot point, if it equals to 0, so it'll be, for example, 0, square root of 0. So square root of 0, if you put that in the calculator, is 0. So that's one solution. So you actually just get one solution, and your solution would look like this. And that's because this part of the equation goes away, it's 0. And then the only thing left over is negative b over 2a. So that's where you get the negative b 2a from. So your discriminant part, your square root part, goes away. I'm just going to get rid of that so it's not kind of in the way. Now, that is going to be our second option. Now, a third option. So we had a plus, positive answer equals to 0 answer, and then we have to look at the negative answer. Have a think about it. If, for example, I'll read the same number, but negative 11. If in the square root I have a negative 11, think about the possibility. So can we actually have the square root of negative 11? If you put that in the calculator, it should give you a bit of an error. We can't square root a negative answer. So this is not a viable option. So basically what that tells us is that there's going to be no real roots. Whenever the discriminant itself is negative, we have no real roots. So just by identifying and looking at the discriminant, which is b squared take 4ac, just looking at that part, we actually get information of how many solutions we have. You can have two distinct real root, that's one of the options. You can have one solution, so one solution we call it, and we can have no real roots. So those are kind of our summary from it. Okay, so let's have a go at the question. So it says use the discriminant, so I'm going to write the discriminant. This is the discriminant, that's what they're telling us to use, and determine the nature of the root. So they're saying use those 3 dot points and tell me, does it have two distinct real roots? Does it have only one solution? Or does it have no real roots? So is it this option? Is it this option? Is it this option? They're asking you to figure out the nature of the roots. So that's what you're trying to do. So in order to do that, again, all you have to really identify is your A, B, and C. Okay? And that's by looking at the coefficients. So that's A because it's in front of the x squared. So remember that our quadratic looks like this. So that one's going to be A, the one in front of x squared, the one in front of x is going to be the B, and then the constant term is C. So A in our case is 2, and then B is negative 2, and then C is 3. So using that, all I need to do is find the discriminant. So therefore, the discriminant is b squared. Make sure I've got brackets. So that is my discriminant. So if I do the maths, or if you put it in the calculator, I get a negative answer. So my discriminant is less than 0. Therefore, if I have a look at my options, it'll be option number 3. There is no real root. So that's what I like. No real roots. That is my answer. All right, having a look at B now. Same again, I'm going to look at my discriminant. And then figure out my A, B, and C in order to do that. And I always like to write it like I am doing, just so it's clear to the marker if you're doing it in the test that these are the numbers you have used. And, you know, even if you accidentally did something wrong, I'll give you some hopefully partial marks for it. So make it clear. If you try to do it in your head, sometimes it doesn't work. Right, 4 times 3 is 12, so now plus 24. Okay, this will be 40. So therefore, my discriminant is greater than 0. So if I have a look at my 3 options, it's the first option where my discriminant is greater than 0. So it'll be 2 distinct real roots. So therefore, 2 distinct real roots. Done. I don't have to actually find it. They just want you to determine the nature of the roots. So you should be able to figure out, start question 1 to 5, whatever I put on the checklist. And you can pause and come back, or listen to this and write this down first, whatever you want. Okay, so for this one, a little bit of a harder example because we have a bit of a constant and we have to rearrange in order to find the values of m for which the equation have a, b, C. We're going to tackle A first. So we want repeated roots. So repeated roots, what that means is if you have a go back to your notes, these are kind of the repeated roots. Only one solution means that it's going to be a repeated root or a double root. So that kind of means that, you know, on our Cartesian coordinate, wherever the root is, it's touching the graph. That's what it just means, and there's only one solution. Whereas, you know, if you have 2 solutions, you're cutting the graph. There's one solution there, 2 solutions there. So that's just what it means, repeated roots. So what we're aiming for is discriminant to equal to 0, because that's number 2 option, how we get repeated roots. So that's what we're aiming for. Let's have a look at our equation. Our equation is x squared take 2x plus m equals 0. Now, I don't need to rearrange it or anything because it has an equal 0 and everything is on one side, so I'm good to go and start to write A, B, C. A, B, C. So I just need to look at the coefficients and figure out my A, B, and C. So my A is 1, so there's a 1 there. B is minus 2. C is m. Now don't freak out, just take your, keep doing what you want to do, and then we'll see how it ends up. So my discriminant formula is b squared take 4ac. So all I need to do is substitute like you normally would, and then we'll see where it takes us. Just a little bit of problem solving. Okay, so this is where I am taken. I can't simplify any further. My discriminant equals to 4 take 4m. Now, going back to kind of our initial idea where our equation, we're aiming for our discriminant to have a repeated root, so the discriminant equals 0. So this is what I'm aiming for. This is where I kind of put that knowledge into use. So I want to find m, values of m, where basically it gives me a repeated root, which is equal to 0. So all I have to do is now rearrange to find my value for m that will give me a repeated root. So what I'm going to do is I'm going to add 4m both sides to make my life easier. So I get 4 equals 4m, and then I'm just going to get rid of the, I want m by itself, divide by 4. So therefore my m equals 1. So this is saying when my m equals 1, this is going to give me a repeated root. Okay, so I've figured my answer. Let's try B. So now there's really, once you do it once, no need for me to kind of redo this whole working out, because it's actually going to be the same up to this part. So this is a fact that I can kind of reuse. I know that, you know, because this equation itself doesn't change. So if you're not sure what I mean by that, if you actually just follow this all step again, you're going to get to the same fact that this is a discriminant we're working with. We just need to figure out what gives me two distinct real roots. So if I scroll up and have a look at my notes again, two distinct real roots is given by option number 1 when discriminant is greater than 0. So what I'm aiming for is this to be greater than 0 as a fact. So I'm trying to find m value where it's going to give me two distinct real roots. So again, I'm going to rearrange it. So again, I'm going to add 4m both sides. So I keep my inequality sign. And then do some rearranging. Here we go. So this is telling me, I'm going to rearrange it so m is first. M is less than 1. So if my m is less than 1, it will give me two distinct real roots. That is what the answer is saying. Let's try C. Again, I can use the same discriminant. And then we want no real roots this time. So no real roots is going to be my option 3. So it's when my discriminant is less than 0. So that is what I'm kind of substituting in. And then all I have to do is again rearrange. Okay, so I'm going to write it as m is something. So m, if I read this inequality, m is greater than 1. So here we go. So now I got my answer. When m is greater than 1, it'll give me no real roots. Now, when you're working with inequalities, which you will for this whole section, this is a note I want you to think about. So you leave the inequality, you keep it constant. I haven't changed it in any of these questions. You only change inequality. So I would write this in the book. Inequality. Oh. Only time you flip inequality, now flip, I mean like changing this to that, like flipping it around, is when you're multiplying or dividing by negative numbers. Okay, this is the only time you flip inequalities. This is kind of year 10 knowledge. Let me know if you need more help with that. If your answer is not looking correct, most likely because you haven't done your rearranging equation correctly. Alright, so you should now be able to do question 6. Obviously, you can see that I've done some hard questions over here. Feel free to look at it only after you've kind of attempted it.